Okay guys, so here's our next mini topic, and it's about the first order differential equations. Now you will remember this, so what I'm going to start with is a wee reminder. So feel free to pause the video at this point and copy this into your notes jotter. So we have seen the first order differential equations, but only in the separable kind. So it's something that we've got that looks like this. You know when we had your dy by dx equals something? So if it's something equals something, then we are able to separate them to get your x's to one side and then the y's to the other side. Okay, so we've seen that before. Okay, the new part is the first order differential equations, which are non-separable. So see when you are not able to put your x's to one side and then y's to the other side. Usually you can tell the difference because it's not something equals something. You've got like something plus something equals something. Does that make sense? That's what we're going to focus on today, and it's a completely different method. Okay, so even although they both are still first order, they are very different. Okay, so it needs to be in the form of this, like just at the bottom here. So you know you've got your dy by dx, which tells you it's first order. Then you've got plus something multiplied by y equals something. Okay, so that's the order that we need the first order non-separable differential equations to be in. Okay, so pause the screen at this point and copy this into your notes jotters, and then we'll get started on the first example. So we're going to have 3 examples here. So we're not going to start by solving them. We just need to check, is this in the correct form? If not, we need to rearrange it. So if I go back a page, this is a form that we need at the bottom. Okay, so we need our dy by dx on the left hand side. Then you need your function in terms of y. You know, you got a y there, so your y needs to be here, and then it's just whatever's left over. It needs to go on the other side. So it's like dy by dx, y, and then whatever. Okay, so if we look at this first example here, so, oops, how do we get this page? There we go. Don't know what happened there. Right, so if we look at this, we've got our dy by dx there, which is good. Then we've got the y term, which is here, and then whatever's left over. So this is actually ready for us to solve that. So I'm just going to write a yes next to here. So that is in the correct form. Okay, so if I have part B here, so x dy by dx, so copy this in, take away 3x squared equals y. Okay, so if you look at part B here, is this in the correct form? Now it's quite easy to see that we've still got a first order differential equation. There's no way that we can get the x's to one side and y's on the other side, so it's not the separable kind. Now the problem lies here with this x term there, because you want nothing in front of your dy by dx. So at the minute this is not in the correct form. So I'm just going to get rid of this x by dividing everything by x individually. Okay, so that'll leave me with something like this. So dy by dx minus, if I divide this by x, you just get 3x there, and if you divide this by x, you just get y over x. Okay, so I've got my dy by dx by itself. It's still not in the correct form, because you want your dy by dx there, then you want your y term, and then anything left over on the other side. So what we're going to do here is I'm going to take away the y on both sides, so y over x, and then I'm going to plus the 3x to bring it over to this side, so you just get 3x there. Okay, now it's in the correct form, like this, because you need your dy by dx, then your y, and then whatever's left over. Okay, so that's just a wee trick that sometimes the exam might do, just to trick you. Okay, so I've got one more question just to test yourselves. So it's dy by dx equals x squared plus xy minus 3. Okay, so quite clearly we've got a first order differential equation. Not in the correct form, because yes, you've got your dy by dx term here, but then you need your y term here. So I am just going to take away all of this to bring it over to the left hand side here. Take away x, y, then everything else can just stay on the right hand side. It doesn't matter if there's 2, 3, whatever terms. like that, now it's in the correct form for us to solve. Okay, so I've not even began solving it yet, we're just rearranging these. Okay, so that's the form that you need in order to solve the first order differential equation. Right, here we write a wee note to show you how we're going to solve them. Okay, so can you copy this into your notes jotter? So these can be solved using an integrating factor. Okay, that's something new, right? So I'm just going to write out the form that we need. So it's dy by dx plus, then you know how you've got something multiplied by our y? We're going to call that p of x y equals, then whatever's left over is just called q of x. Got no idea why they use p and q, they just do. Okay, so p of x is just whatever's attached to the y. That's it. Okay, so I'm just going to write in here. So p of x equals the function attached to the y. Okay, and that function, so whatever's attached to the y, it helps us to work out what the integrating factor is. So that's your next bullet point. So integrating factor. So we're just going to call that a capital I. That stands for the integrating factor. Okay, and what it is, it's just another formula you need to remember, and it's going to be e, so the exponential, to the power of the integral of p of x. Right? So whatever's attached to the y, that's what you need to integrate as the power. And I'm afraid you just need to remember that. Then once you've worked out your integrating factor, then there's another formula that you need to remember. So then we use this formula. So it's iy equals the integral of iq. Now I have not found any nice ways to remember this yet, but if any of you guys come up with a rhyme or something to help me remember this, then I would gladly take it on board. So I is just your integrating factor, and y is just y, equals integral of iq. Okay, so iq is quite easy to remember because your iq is your intelligence questionnaire, iq. So if you're able to know these two formulas, then that's how you solve these first order non-separable differential equations. Bit of a mouthful, isn't it? Right, let's do 3 examples. Examples. So it does start off with easier ones. So number 1, find the general solution to, so dy by dx plus y over x equals 1. Okay, so it's quite obvious here we've got a first order differential equation. It's not written in the form like something equals something, so we cannot separate it. Okay, what we're first of all going to do is we're going to write out our 2 formulas that you just need to remember. Okay, so it's I, which is our integrating factor, equals e to the power of the integral of p of x, and then iy equals the integral of iq. Right, those are the 2 formulas that you need to remember. Okay, there's no easy way to do it, just the more you write these out, the more you'll remember it. Okay, so let's start with working out our integrating factor. So it's going to be e to the power of the integral of, now p of x here, that's whatever's attached to the y. In case you're not including the y in here, it's what's attached to it, so it's over x in this case. So p of x, I'll write it here if you want, is just going to be 1 over x. Right, so whatever's attached to the y here. So you're going to work out the integral of 1 over x, and obviously that's with respect to x. Right, so if we work out the power of, the integral of 1 over x, this is just our special case, because the derivative of the bottom is 1, which we've got on top. Happy days, so it's just going to be ln of the bottom, like this. Okay, now we're not going to write plus c in here for our constant. The reason why is because we'll deal with the constant on this side, and that will just encompass all of the constants. Now what always happens here is that it will cancel down to be really nice. Now can you see we've got an e and an ln next to each other, and they're actually opposites of each other, so they cancel off. So our integrating factor here is just going to be x in this case, right? And that will always cancel in some way or form to make your life that little bit easier, right? So that gets you a mark for working out integrating factor. Now we go over to this side. So see you've got I on both sides. So I, we've just worked out it's going to be x in here. So here you just get xy, because y just says y, equals the integral of I, which we've worked to be x, and q is just whatever's on this side. So we've just got a 1 on this side. So here we've basically got x times 1, which is just x dx. So all we need to do now is to integrate this and then rearrange it so I've got y by itself, and that's your general solution. So I'm going to keep this part the same. Let's integrate to the x. So just increase the power, divide by the new power, plus c. So that constant obviously encompasses both parts. Then one more thing, you just need to get y by itself, and that's you've got your general solution. Okay, so to get y by itself, all we're going to do is divide everything by x here. So if you divide this by x, you just get x over 2, and if you divide this by x, you just get c over x. And there's nothing else that you can do to simplify that. So that is your general solution, and then that is your finished. Okay, so the hardest thing about this, I think, is remembering these two formulas up here. So if I were you, I would write these down on your formula sheet, just so you remember them. Right, second example, so we've got 3 in total. So number 2, same again, find the general solution. It's x times dy by dx plus, open bracket, x take 2, close bracket, times y, equals x cubed. Okay, so if we need to find the general solution to this, it's dead easy as a spot. We've got a first order. Okay, you don't have something equal something, so you're unable to separate this. So we need to use the non-separable method. So if you do a wee check, is this in the correct format first of all? And the answer is no, because you've not got your dy by dx by itself. So what I'm going to do is start by dividing everything through by x, okay? And that will allow you to have your dy by dx by itself. So if you divide this by x, I'm just literally going to put x on the bottom, like this. And if you divide this by x, it just gives you x squared. Is this in the correct form? So you've got your dy by dx by itself, you've got your y term here, equals this. Yes, this is in the correct form. So start by writing down your two formulas. So I equals e to the power of the integral of p of x, and then I, y, equals the integral of I cubed. Right, let's start over here. So e to the power of the integral. Okay, so what's p of x? So p of x is whatever's attached to the x term here. So that's going to be x take 2 over x dx. Just like that. Right. Now, the hard part here is actually integrating this part. So it's not this special case, because the derivative of the bottom is 1. You don't have 1 on the top. Okay, so it's not going to be that. What we could do is actually separate this. So I'm still going to keep as e to the power of the integral of. So separate that into two fractions. So you're going to have x over x, take away 2 over x dx. Now obviously this can simplify a wee bit more before we integrate it. So x over x is just 1, and then take away your 2 over x, that can just stay is 2 over x. Okay, so now we're ready to integrate this. So integrate them individually. So if you integrate 1, you're just going to get x in there. If you integrate the second part, this is going to be your special case, but with 2 at the front, so it's 2 ln x. Remember, we don't put plus c in here, because we deal with the constant on the right hand side. Now, this looks a bit messy, okay, but we are able to simplify this a little bit more, okay, particularly because I can see an e in here and I can see an ln. Now, I know that they're opposites, but we are not able to cancel them off just yet, right? Now we're going to use the rules of indices and split this up. So this is basically like saying e to the x times e to the minus 2 ln x, like that. Because if you multiply two things, you add the powers, which is basically what we're doing. We're just undoing that. Okay. Now the first part, e to the x, nothing you can do to that to simplify this. The next part, your e and your ln are still not side by side, and it's this minus 2 that's the issue. But what I can do to that, using the rules of logs, if I bring the minus 2 up as a power, up here with the x, that means your e and your ln will be next to each other, which is what I want. So I'm going to keep my e to the x there, bring your minus 2 up to the power, so it's ln x to the power of minus 2. Just keep my modular signs in here. Now you've got your e and your ln next to each other, so they can cancel. So it leaves you with e to the power of x times x to the minus 2, which if you bring the x to the minus 2 down to the bottom, it just gives you e to the x over x squared. There's nothing else we can do to simplify that. So you have to simplify your integrating factor as much as possible, and you'll see why that helps us when we do the right hand side. Okay, so I'm just going to put a bubble or highlight this, because that's going to be your integrating factor. So if I go back up to this side, so I've got I times y, so I was e to the x over x squared. So if I write that in here, so e to the, so e to the x over x squared Okay, so that's going to be I times that by y equals. So here we've got the integral of iq. So if I write I, and again, so e to the x over x squared times by q. So q is whatever's on the right hand side, which is x squared dx. You're probably going to see what's going to happen on this side. So this part can just stay the same. Now remember I said something always cancels off to be really nice, and that happens here. Your x squared and your x squares, they cancel. Now that, if you hadn't have simplified your integrating factor all the way down, you would really struggle to integrate this, and that's why it's so important that you simplify this all the way down. Now, this is actually quite a difficult example I'm going through right now. Most of them are a little bit easier than this. Right, so if they cancel, it just leaves you with the integral of e to the x dx, which is so much easier to integrate. Right, so this side stays the same. The integral of e to the x is just e to the x plus c. Then all you need to do is get y by itself, and then you're done, pretty much. So I'm going to start by multiplying everything through by x squared. So I'm going to have x squared e to the x plus cx squared, and then divide everything by e to the x. And that means you've got y by itself. So if I divide that by e to the x, I've got an e to the x there, so just get x squared. And if you divide this by e to the x, just stick it on the bottom. Done. So that is now your general solution. Okay, so the hardest part about this, I reckon, is getting your integrating factor and simplifying that all the way down. Okay, everything else, if you just follow the formula, it does work out really nicely. Trust me. Okay, right, one final example. This will be number 3. So dy by dx minus 2y equals 6e to the minus x. Okay, and your question's the same. It's just going to be find the general solution. Okay, so obviously we've got a first order. We don't have something equals something, so it's going to be the non-separable ones. I would always start by writing your formulas. So I equals e to the power of p x, and then I, y equals integral of I, q. I would always start by doing this. Okay, right, so here we're going to have e. In fact, did I double check that? Is this in the right form just now? So we've got our dy by dx by itself, which is good. Then I've got my y term, which is good. Then whatever's left over. So yeah, this is actually in the correct form. I just forgot to check. Right, so you're going to have e to the power of the integral of p of x. So it's whatever's attached to the y. So in this case, I've got minus 2 attached to the y. So that's what I'm integrating. Okay, so if you integrate this, you're just going to get minus 2x. You don't put your constant in there. Is there anything that I can do to simplify this? No. There's no ln's that I can cancel. So no, that's actually quite easy. Right, back to this side. So by now you've already got the formula down. I, y. So I is going to be e to the minus 2x. Y is just y. Equals the integral of I, which is e to the minus 2x, times q, which is that part. So it's 6e to the minus x dx. Okay, so if you look at this, I'm going to keep the left hand side just the same. Just focus on integrating the right hand side. So at the minute it's not ready for integration, so these two things are multiplied together. So if we multiply these two things together, you're adding the powers. So I'll keep my 6 at the front. So if you do minus 2x add minus x, it just gives you minus 3x. Just like that. Okay, see how everything comes together really nicely here? So now we're ready for integration. So if you integrate an exponential, your exponential stays the same, and you divide by the derivative of the power. So you're dividing by minus 3 here. Plus you've got your plus c at the end. Right, let's simplify that part. So 6 over minus 3, it just gives you minus 2 e to the minus 3x plus c. And then remember, we need to get y by itself. So you could write this on each line if you want. It's not necessary. Like this. And then to finish it off, we just need to get y by itself. So I'm just going to divide everything by minus 2x. Right. So I'm just going to show working for this part, just to find it easier for myself. So if I divide this by minus 2x, I'm just going to write in that on the bottom, like this. And if you divide that by minus 2x, straight on the bottom like this. This can be simplified here. So if we look at the first bit here, I write minus 2, it's just at the front. So if you bring this, whatever's on the bottom, if you bring that up to the top, you change the sign of it. So it goes from minus 2x to plus 2x. So you get minus 3x plus 2x. It just gives you e to the minus x. Plus. This part you could keep it the same if you want, or you could bring the bit up to the top to change the sign to a positive. Then you could bring that part back down to the bottom. I'm just going to leave it like here. That's your general solution. You've got y by itself and you have simplified. Okay, so the hardest thing about these, I think, is remembering the formulas and simplifying your integrating factor, which in this case is actually pretty easy. Okay, right, time for some questions. Okay, so here are some questions that I want you to try. So feel free to pause the video at this point, or take a screenshot or whatever. So same thing for all of these, I just want you to find the general solution. Okay, and I'll stick up the answers in the next couple of seconds. Okay, so that's the answers that I'm looking for each of these. Okay, and same as always, if you've got any questions, then please let me know.